Okay, once again, good morning to you all. So, in parameter passing mechanisms, I would like to summarize on a few things. We have three types of parameter passing mechanisms as we discussed in the previous class. The three types are the first one, which is going to be called by name, and second one, which is going to be called by value, and third one, which is going to be called by reference. So, these are the three types of parameter transmission mechanisms that we have. We used to call this parameter transmission as parameter passing mechanism sometimes, but the title here is parameter transmission. Okay, the title is going to be parameter transmission. So we have some three types over here. Among those three types, the important things are the first two types, call by value and call by reference. Those two types are very important, and to the last we have call by name. That's going to be with some least important. We won't give much importance to that call by name, but we must know the differences between call by value and call by references. Now I'm going to give the differences between call by value and call by references. As we discussed in the earlier class, the first difference, which is going to be where in call by value we used to use duplicate value and we used to process, where in call by reference we used to use the original value. This is going to be the first difference. So under call by value we are going to use a duplicate value and for processing, whereas in call by reference we are going to use the original value and then we are going to process. That's going to be the first difference. And then the second difference is in call by value, um, we are going to use a normal variable for passing the value between the function call or calling function and then function definition. We are going to use a normal variable, whereas in call by reference we are going to use the variable with addresses. So those addresses which is going to act like reference parameter for us. Okay, so you will have variable name with its addresses in call by reference, whereas in call by value you will have a normal variable alone. That's going to be the second differences between call by value and call by reference. And then the third important differences, this is very important thing. The third important difference is very important. So in call by value, whatever the changes that you're going to do in function definition, it won't reflect in main function. Okay, because we are going to take a copy of value for processing, so we are not going to disturb the original value over there. So just we are going to take a copy of value. That's why we used to call it as a duplicate value, the copy of value which has been referred as duplicate value over here. So just we are going to take a duplicate value and then we are going to process. So whatever the original value that we have in the main function, it won't get disturbed, so it will be as such, the value will be as such. So whatever the changes that you're going to do in a function definition, it won't reflect in main function. Okay, this is going to be the third important differences. Whereas in call by reference, whatever the changes that you're going to do in function definition will reflect in main function. So uh, just to create a picture or imagine like this, just we are going to use two functions, a main function and then a function one. Okay, we are using two functions in this program. We have a main function and then we will have a function one. So from the main function you're going to call this function definition, the definition of the function one. So we'll have some function call. So from the main function you're going to call the function definition. So from the main function you're going to pass the variable's address. So what will we use? So along with your variable name we used to use the ampersand operator. For example, the function name which is going to be sum, which is going to be the function name. So in the main function, the function call which consists of what? Sum, opening bracket, ampersand a comma ampersand b and closing bracket. So this is going to be the function call which presents within your main function. And then in the function definition you will have void sum, opening bracket, integer, ampersand a comma integer ampersand b. Okay, so here while declaring it as a parameter here, actually we have to use one more operator. The operator we used to call it as a pointer operator. Okay, the pointer as an important operator. So you will have like this. So integer asterisk a comma integer asterisk b. Okay, but while passing the value you have to mention it with some ampersand. So sum of ampersand a comma ampersand b. So the ampersand a value will be passing to this asterisk a, and ampersand b value will be passing to this asterisk b, and then here um, we are going to process it. Okay, so in the function definition you are going to process it. So actually the original value will be passing from the main function to the function definition, and then here we are going to process something, and after processing the results will be returned to the main function. Okay, so whatever the changes that you have done over there will be reflecting in your main function. Suppose if you are taking the value 1 and 2, and then you are doing some logic processing over there, and after applying those logics, whatever the resultant value that's going to come to those variable, that will be passed to the main function. Okay, maybe the value will get changed, or it may pass some single value. So whatever the value is going to return, that value will be moved from the function definition to main function, and then the value will be the resultant value will be printed as an output. Okay, so here the important thing is the changes whatever that you're going to do in function definition will reflect in your main function. So that's going to be the third important differences that we have between call by value and call by references. Okay, so where in call by value we used to use normal variable, whereas in call by reference we used to use pointer variables. So we used to use two symbols over here as ampersand as address operator and asterisk as a pointer operator, and then we are going to take the original value and then we are going to process over here. So that's going to be the third important differences that we have in your call by value and call by references. Okay, so with this I would like to complete this topic, parameter transmissions. So if you have any doubts in this parameter transmission mechanisms, you could ask me now. So you could post your questions in chat box so that I will answer. So whatever may be the question that you want to ask to me now related to parameter transmission mechanisms, you could ask me now. If you have any doubts or if you have any clarifications, if you need any clarifications, you could post your questions in chat box. If you don't have any doubts, you could type a 0 in your chat box. If you don't have any, so Shruti has asked me some question. Definition for calling and called functions. Again, okay. Repeat it again once again. Definitions for calling and called functions. Okay. Most of the time we used to get these confusions. So what is the difference between calling function and called function? Okay, so this is going to be the question. What is the difference between calling function and called function? Whatever the function call that we have within main function, whatever the function call that we have within main function, we used to call it as in calling function. Okay, so whatever the function call that we have within main function, we used to call it as an calling function. So calling function will be present within your main function. Okay, so the calling function isn't just a control, it's going to call another function. Okay, just by using its name and using its parameter, we are going to call a corresponding function actually. Okay, so calling function will be present within your main function, and then called function means the function definition whatever that we have outside the main function, that's going to be about called function. The function definition which present outside the main function will be referred as called function. So don't be in confusion between calling function and called function. So calling function in the sense just it's going to invoke a function. So from here the control moves to a function definition and it's going to invoke the function. Okay, where the function definition which has been referred as what called function. Okay, and this function definition which consists of some statements which is going to do some process over there. So this is going to be the differences between called function and calling function. So calling function which will be present within your main function, where called function which will be present outside your main function. So other name for calling function is function call. The other the other name for calling function is function call. Okay, and then other name for function definition is called function. The other name for function definition is called function. Okay, so this is going to be the differences between calling function and called function. um, uh, Shruti, is it clear, ma? Shruti, is it clear?
Yes, sir.
Okay,
Yes, sir.
okay, ma. Okay. Do uh, do any of you have any other doubts regarding parameter transmissions? So this question, which is going to be a very very important question, ma, to the maximum to for about 80 percentage, 80 for about 80 percentage, we could expect this question in university examinations. Okay. So if you have any doubts, you could ask me now, or else type 0. If you don't have any doubts, you could type 0 in your chat box, or else if you have any doubts, you could ask me some questions. So Hari has typed it as 0. Okay. Shall I start the next topic? So I will be posting some questions at the end of the session. Before that, I would like to take the next topic, cover some important points in the next topic. Um, so shall I start the next topic?
Yes, sir.
Okay, okay. Um, okay, good. So the next topic, which is going to be uh, finite automaton. This is going to be one of the important topic. Finite automaton. This is going to be one of the very very important topic in your unit 1. So to the maximum 95 percentage, we could expect this particular topic in your university examination, finite automaton. So the entire unit 1, which is based on this particular concepts, finite automaton. So finite means which is nothing but which has a finite number of steps. So using some finite number of steps, we are going to do something that's about finite automaton, in the sense automatically like a machine it's going to do its work. That's about automaton. So we used to call this um, topic as finite automaton, and then here this finite automaton which works similar to your lexical analyzer. And then here we used to call this finite automaton with some various names. The first name is finite automaton, and second name is lexical analyzer, and then third name is recognizer. RECOGNIZER. So we used to call this finite automaton with two other names. The two other names are lexical analyzer, or else we used to call it as an recognizer. Okay. The purpose of lexical analyzer, you people know very well about the purpose of lexical analyzer. The other name for lexical analyzer is, we used to call it as a scanner, actually, SCANNER, scanner. So the purpose of this scanner is, it used to take some source code, or it used to take some program as an input, and then by grouping some sequence of characters, it used to frame some meaningful token. Okay, meaningful words, and meaningful words will be converted into lexemes, and from the lexemes we used to define the tokens. So this is the normal process of lexical analyzer. So taking a program and first finding out the lexemes, and from the lexemes to define some tokens. So this is going to be the normal process that we have related to lexical analyzer. So here, instead of lexical analyzer, we are going to create some prototype. That particular prototype, which is going to act like some uh, machine for us, that particular prototype, which used to perform the work of lexical analyzer. So this particular prototype, we used to call it as a recognizer. Okay, this particular prototype, we used to call it as a recognizer, which used to perform the work of lexical analyzer. Okay, and then how this recognizer which used to work, this is going to be the next obvious question that automatically arises in our mind. This recognizer which used to work in a way that we are going to give some input to it, and then it used to check whether that particular string is an acceptable one or not. It used to check whether the string is an acceptable one or not. So based on that it will decide whether to accept that string or not. Suppose if it's going to be an acceptable, it will accept, or else it's going to reject. So it used to give them two answers over here, either yes or no. So we are going to take a recognizer which is a prototype for us. To this we are going to pass some input string actually, and then after passing the input string, which is going to give some two answers, either as yes or not. Yes in the sense the input string is acceptable, no in the sense the input string is not acceptable. Okay, so suppose if the recognizer would be able to recognize that string, it used to give the results as yes. Suppose if the recognizer won't able to recognize the string, it is going to give the results as no. So these are the two probable answers that we have, either yes or no. Okay, and then for this recognizer we are going to use a notation for developing a prototype, or notation for processing. Those notation we used to call it as in regular expressions. Okay, so this is going to be one of the important concepts that we have in finite automaton, the concept named as in regular expressions. So based on these regular expressions only, we would decide, or your recognizer would decide whether the input string is present or not. If the input string is present, it's going to give the results as yes. If the input string is not present, it is going to give the results as no. Okay, so the notation, so for each and every concept we have some notation that to be used, and based on the notation only that particular tool that it used to work. So here the tool that we are going to use is recognizer, which is a prototype for us, and then this particular prototype will give some results to us as the input string is acceptable or not, whether the input string is present or not actually. Okay, suppose the input string is present, it will give the answer as yes. The input string is not present, it's going to give the answer as no. Okay, so this is going to be the overall story of this recognizer. And then the next thing, which is about regular expressions. The regular expression, which means we have the combinations of mm, uh, we will have the operands, and then you will have the operator, and then you will have some those combinations in these regular expressions. So the combinations of operators and operands in basic we used to call it as in regular expressions. Now I will give some examples for regular expressions in your chat box now. Vinusri, start presenting the presentation, ma. um, Vinusri, are you there? Hello. Okay, okay. uh, Switch off your mic please. So I will post some regular expressions in the chat box now. So the regular expression will looks like this. So you will have some opening bracket, and then you will have a, and then you will have the vertical line symbol, actually we used to call it an or symbol, and then you will have b, and then you will have an closing bracket over there, and then to the top of the closing bracket you will have asterisk, and then you will have abb. So this is going to be the regular expression. Okay, so in the chat box I have given the example for regular expression. You will have an opening bracket a, you will have a vertical line, though we have don't have that particular symbol, I have mentioned it as r slash. Okay, and then you will have b, and then you have a closing bracket, and then you will have to the top of a slash b you will have an asterisk. Okay, and then it will be ending with a b b. So this is going to be the example for regular expression. In this particular notation, we used to have many more things that to be understand by us. We have many more things that to be learned by us. So a or b to the power of asterisk. Okay, the asterisk which denotes one or more repetitions of a or b. The asterisk at the top of A or B, which denotes one or more repetitions of A or B. So you could have any number of A's or you could have any number of B's, and then it will be ending with ABB. So whatever this thing that you are going to get, the condition here is it have to be end with ABB. So this is going to be the regular expression that we have. So before ABB, you could have any number of A or any number of B. So this is going to be the combinations. So you will have the combinations of any number of a or any number of b, but it must end with abb. So this is going to be the condition that we have in this regular expression. Mm, okay, so this is going to be the overall concept that we have. The purpose of this recognizer or this lexical analyzer is, suppose in your program you're going to have some keywords, the keywords which is going to be if, or the keywords which is going to be else, or the keyword which is going to be like switch, or the keyword which is going to be like break. So to check it out whether these keywords is present or not, first your prototype or this recognizer have to check. Suppose if going to be an if, it have to check for whether the first character is I, and then next it have to check for f. Suppose if we get both of these character I and f, then it's going to give the results as yes. Suppose while checking for this if, suppose we have I but we don't have f, and then it's going to give the results as no. Okay, and similarly the next keyword which is going to be else, else, your lexical analyzer is going to check for this particular keyword. First it used to check for e, and then it used to check for l, and then it used to check for s, and then it used to check for e. So we must need all those four character e, l, s, e, else. Okay, suppose if any one of these character is going to be missed in those representation, okay, or while recognizing those input strings, then it is going to give the results as no. Okay, if all of those characters is present while recognizing, it used to give the results as that else is present, and then it's going to give the results as yes. So this is how actually, this is the purpose of your recognizer. Okay, this is the purpose of to recognize some keywords, to recognize some words as a token. We are going to use this recognizer as an option. And then as I already told, the recognizers are nothing but what it could be called as lexical analyzer, or it could be called as a prototype for lexical analyzer, or it could be called as a scanner, or else we used to call it as a finite automaton machine. And the same thing which will be called with some different terminologies. That's why sometimes the students wouldn't be able to get a clear image of those concepts, but we are referring the same thing with some different terms. um, so earlier in the previous topic, the same thing, the same terminology function could be referred as routines, or it could be referred as procedures, or it could be referred as subroutines. But all those things which refers to as what functions, or it could be even referred as methods. So but all those things which refers to what functions. Similarly here, the same thing, we have a tool, the tool which is going to be what lexical analyzer. This tool could be called with some different names as finite automaton machine, okay, and then recognizer, and then or else we used to call it as a scanner, SCANNER. So the same thing could be called with some different names. That's going to be the thing over here. And then here in this finite automaton, we have some two important categories. So finite automaton machine could be divided into some two major groups. The first one, which is going to be DFA, and then second one, which is going to be NFA. So these are the two major subdivisions that we have under finite automaton machine. Okay, where NFA, this is going to be the first type. We used to call it as a non-deterministic finite automaton. Throughout this session, we are going to discuss on this NFA alone, non-deterministic finite automaton. The next one, which is going to be about DFA, deterministic finite automaton. Okay, so here first we are going to learn on this NFA, and next we are going to learn on DFA. So from NFA we used to construct DFA. From DFA we used to construct actually a program. That particular program which used to act like your lexical analyzer. Okay, so from NFA we are going to construct DFA. From DFA we are going to construct a recognizer. That particular recognizer or prototype, which is going to act like a program for us, which used to works like lexical analyzer. Okay, so this is going to be the flow of how we are going to get into the path of this finite automaton. The first one I would like to discuss on this NFA, non-deterministic finite automaton. So you have some diagrammatic representation for this. So in this diagrammatic representation, you have some symbols. Those symbols will be discussed in these presentations. So you will have some state numbers, and you have some symbols, and using that we used to draw some diagrammatic representation, and we used to call those diagrams as NFA, or else we used to call it as a transition diagram. We used to call it as a transition diagram. Okay, those transition diagrams, the purpose of those transition diagrams are to recognize some input strings. For recognizing input strings, we are going to use those transition diagrams. So the transition diagrams could be called as the NFA diagram or DFA diagram. We used to call it with some other names. And then after drawing those diagram, with that particular diagram, we used to create a table. We used to call that particular table as transition table. Okay, so first we are going to draw a transition diagram. Sometimes we used to call it a transition graph. Basically that's going to be an NFA and DFA, and then out of those things we are going to draw a table, the table which is going to be the transition table. Okay, so from the finite automaton, first essentially we're going to divide it into two forms as NFA and DFA. From NFA we're going to draw transition diagram, and from transition diagram we are going to draw transition table. So these are the flow of this particular topic. Okay, and then coming to the presentation, so here we are going to have what input program. So we are going to put this input program into lexical analyzer, and then it's going to recognize those source code, and then we are going to find out the lexemes or tokens. But at the heart of these transitions, that's going to be very important. So at the heart of these transitions, between the input and getting the output, between these input and output, that's going to be the transition. The formalism or the idea or the logic that we have over here is finite automata. Okay, so between the input and output, whatever the thing, whatever the strategies that we're going to follow, or whatever the technique or whatever the logic that we're going to follow, we used to call this logic or technique as finite automata. As already I told you, finite means some particular number of steps, finite number of steps. Automaton means a machine. A machine, what it used to do, it used to automatically, it used to do something. I hope you people have learned this NFER, DFER, finite automaton in your mathematics paper. And then the concept whatever that we have over there and here, it's going to be entirely somewhat different. And then so these are some essential graphs, and then these graphs we used to call it as transition diagrams. So we have some few differences whatever that we have over here. So the first thing, so finite automata which is going to act like what, recognizer, and then simply it's going to tell yes or no. Okay, so suppose if the input string is present, it is to give the results as yes. Suppose if the input string is absent, it is going to give the results as no. Okay, so so imagine like this, or create and view like this. So you have some machine with you. So take a box within your hand, and you have a box within you at your hand now. So this is going to be the finite automaton. This box which is going to act like what? Finite automaton. Okay. And to this we are going to give some input. For example, the first input that I'm going to give is if, and then second input I'm going to give is else, and then third input I'm going to give is switch, and then fourth input I'm going to give is break. Okay. And this box which is going to recognize it, that's why we used to call it as a recognizer. Okay. And then it used to give two results, either as yes or f. Okay. Suppose if this box would be able to recognize if, it used to give the results as yes. Suppose if it wouldn't be able to recognize that if, it used to give the results as no. Similarly, next it tries to recognize else. Okay. Suppose if this box would be able to recognize the word else, it used to give the answer as yes. Suppose if it wouldn't be able to recognize that particular word else, it is going to give the results as no. So this is what actually will happen over here in this finite automaton. So finite automaton is nothing but which is a recognizer, which is used to recognize some keywords or some other words. It's going to be in like seams, or else we used to call them tokens. Suppose if it would be able to identify the presence of that particular input string, it will give the results as yes. Suppose if the input string is absent, it is going to give the results as no. So this is going to be the overall process that we have. And then we have two flavors of this transition diagram or finite automaton. The first one which is going to be NFA, and second one which is going to be DFA. Where NFA, the abbreviation of the NFA is non-deterministic finite automaton, and then the next one DFA, which stands for deterministic finite automaton. Okay, so we have some two flavors in this finite automaton machine. And then why we need to have some two flavors? And just with one flavor we could work on these recognizing problems. And then why we need some two types of flavors over here? Actually, the first thing that we need here is NFA. Using NFA only you would be able to derive DFA. Okay. And using DFA only you would be able to derive a program. That program only which is to act like an recognizer for us. Okay. So ultimately the DFA which is depend on NFA, and the program which is a prototype whatever that we are going to develop which is depend on this DFA. Okay, so you will have an NFA arrow mark, DFA arrow mark, and then you have a program. Okay, which is going to be a sequential step of process that will be followed. Directly we won't be able to get DFA, and directly we won't be able to get a program. Okay. Actually we used to simulate a DFA into a program. We used to call it a simulation process. We used to simulate a DFA into a program. That particular program which is going to be an output, or which is going to be a prototype for us actually, which used to works like an recognizer. Okay. So we have some two types, NFA and DFA. We have some major differences between this NFA and DFA. The first differences between NFA and DFA, EFA is NFA, which used to have some two symbols within it. The first symbol, it used to recognize the same label more than once in the transitions of the same diagram. So it used to use the same label as an outer directed edges. I will tell you about those things with some diagrammatic representation, so you will get some clear idea. But this is going to be the actual differences. So the first difference is it used to transfer the same label more than once from the same state. Okay, the same label in the sense, for example, if which is going to be in keyword, the first character I which is going to be in label, and f which is going to be in another label. Suppose if in the diagram the same label which has been transferred from one state to another state more than once, we used to call that particular diagram as an NFA diagram. Whereas in DFA, the same label will transfer from one state to another state only once. This is a very important difference. In NFA, the same label will transfer from one state to another state more than once. In DFA, the same label will transfer from one state to another state only once. This is going to be an important first difference that we have. And in NFA, you have the options of using the empty string from transferring from one state to another state. But in DFA, we won't use the empty string option. The empty string, which has been referred as belongs to symbol over here, belongs to symbol. So that particular belongs to symbol will be present in NFA and it won't be present in DFA. So these are the two important major differences that we have between NFA and DFA. So far I have given some introduction to finite automaton, and then uh, the differences between NFA and DFA and about recognizers. So these are the things that we have discussed so far. Now the time is up. With some question session, I would like to complete this session. So I'm going to ask some basic questions. Don't be fearful to answer these questions. Just I'm going to ask some basic questions. So whatever the answer that you people know, post those answers in your chat box. Whatever may be the answer that you people know, okay, related to that particular questions. Okay. Um, the first question. What is the other name for parameter? What is the other name for parameter? Very fast. Arguments, arguments, arguments. Very good, very good, very good. Very good, ma. Very good. The answers are very appropriate. Exact answers. Who is the first one? Shruti. And then Vinusri, and then Manjula, Deepika, Sindhu, Deepak, Cyril, Jyoti, Jyotikmar, Induja, Nijantan, Rohit Balaji, Pravina, Goiklavani, Mohan Prasad. Okay. So most of you have answered it very correctly. So that's the right answer, ma. The other name for parameter is arguments. Very good, very good. The answer is very exact. And then the next question, what are the three types of parameter transmission mechanisms we have? What are the three types of parameter transmission mechanisms that we have? Parameter passing mechanisms that we have. We have three types. Okay, very good, very good. Vinusri is the first one who answered it, and then Deepika, and then Shruti. Okay, so the answer, these are the answers. Very good, very good. And then Cyril, and then Manjula, Rohit Balaji, Induja, Nirmal Vincent, Hari Prakash, Shruti. Okay, Nirmal Vincent, Jyoti Kumar, Mohan Prasad, Deepak. So this is going to be the very right answer. The answer is the first one, which is called by value, and then called by reference, and then called by name. Okay. So these are the exact answers that you have given. Very good, my dear students. And then third question. Okay. The third question, which is going to be, what is the other name for call by name? What is the other name for call by name? Very fast. Deepika. The first one is, who is the first one? The first one is Deepika. Thanks. THUNKS, and then Venusri, and then Deepak, and then Induja, and then Hariprakash, Manjula, and then Shruti, and Darshana, Jyotikmar, Satyamurthy, Pravina, Nijantan, Sindhu, Nirmal, and then Cyril. Okay, the answer is exact, and the answer is very correct. The other name for call by name is thanks. THUNKS. Thanks. Okay. Very good, very good. And then the next question is the next question is um, um, give me any one difference between call by value and call by reference. Give me any one difference between call by value and call by reference. Any one difference. We have total of 3 differences, but you could answer any one of the differences between call by value and call by reference. The first one is the call by value. Duplicate value, call by reference, original value will be passed. Very good, very good, very good. And then any other answers? The differences, any one differences between call by value and call by reference. Who is the next one who have answered? Deepika. Original value is used while process and duplicate value is used while process. Deepika, to be clear, in call by value only we have to use duplicate. In call by value, call by references only we have to use original value. Okay, you have answered it, but you have answered it in an opposite manner. Okay, so and then who is the next one who have answered? Shruti have answered it right. Call by value changes doesn't reflect, and call by reference changes reflects in main function. Okay, that's going to be the second difference. That's going to be the second difference, where whatever the changes that you're going to do in your function definition will reflect in main function, will reflect, which denotes the call by reference. Won't reflect, WONT, won't reflect in main function, which refers to call by value. So Shruti has answered it very correctly, and then Jyoti Kumar also answered it correctly, and Vinusri, in call by value calling function passed a copy of value. Okay, okay, good, okay, the answer is right. And then Induja have answered it in different memory location, in same memory location. Okay, 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 ma, okay. So so most of you have answered it very correctly, so thank you for answering. And then the Jyoti Kumar, call by value, call by variable names. Okay, and then the last question here, what are the two types of finite automaton that we have? What are the two types of finite automaton that we have? Deepak, who is the first one? NFA and DFA. So Deepak have answered it first, and then Manjula, and then Hari, and then Sindhu, and then Jyoti Kumar, and then Mohan Prasad, Venusri, Deepika, Pravina, Darshana, Rohit, Gogilavane, Nishant Kumar. Okay, so most of you have answered it very correctly. Okay, so with this I would like to stop the presentation, stop the session. So thank you students, thank you very much. You people are listening very well, and then you people are answering very effectively. So thank you very much for listening very patiently. The absentees are roll number 13, 32 and 33, just 3 absentees. Roll number 13, 32 and 33, we have 3 absentees in this hour. So thank you students, thank you for listening, thank you.